है लॉन्ग आंसर क्वेश्चन चे आंसर की फर्स्ट क्वेश्चन ऑब्टेन एन एक्सप्रेशन अपॉन पोटेंशियल एनर्जी ऑफ ए हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शालेय शिक्षण क्रीडा विभागाची 2023 मध्ये क्वेश्चन बँक फिजिक्स या विषयाची पाठवली होती. त्याची आज आपण आन्सर की बघणार आहोत. आज आपण इलेक्ट्रोस्टॅटिक हा चॅप्टर पाहतोय आणि त्याच्यात लॉंग आन्सर क्वेश्चनवर आलेलो आहोत. आज आपण लॉंग आन्सर क्वेश्चन बघणार आहोत. चला तर मग त्या लॉंग आन्सर क्वेश्चन लॉंग आन्सर क्वेश्चन याची एकूण 3 आहेत. याची आन्सर की आपण PDF स्वरूपात बघूयात. चला तर मग त्या आन्सर की जवळ लॉन्ग आंसर क्वेश्चन चे आंसर की फर्स्ट क्वेश्चन ऑब्टेन एन एक्सप्रेशन अपॉन पोटेंशियल एनर्जी ऑफ ए डायपोल इन एन एक्सटर्नल फील्ड. आंसर first, consider a dipole with a charge minus q and plus u separated by a finite distance 2l placed in uniform electric field E bar. Second, it is experienced at a torque tau which tends of rotating as shown in figure below. Tau bar is equal to p bar into E bar is equal to p sin theta. here a diagram couple acting on a dipole. Third, to neutralize this torque, let us assume an external torque T external be applied, which rotate in the plane of the paper from angle theta 0 to angle theta without angular acceleration and at infinitesimal angular speed. If work done by external torque W is equal to theta integration theta 0 to theta tau external into bracket theta into d theta is equal to integration theta 0 to theta p is sin theta into d theta is equal to p into bracket minus cos theta 0 to theta is equal to p into bracket minus cos theta minus into bracket minus cos theta 0 bracket complete p is equal to into bracket minus cos theta plus cos theta 0 bracket complete. This is equal to p into bracket cos theta minus cos theta. This work done is stored as the potential energy of the system in the positions when the dipole makes an angle theta with the electric field. 5. This potential energy of electric dipole in external electric field is u theta minus u theta 0 is equal to p into bracket cos theta 0 minus cos theta. Question number second, find the capacitance of a parallel plate capacitor with dielectric slab between the plates. Answer, first consider a parallel plate capacitor with the two plates each of area A separated by a distance d. The capacitance of the capacitor is given by C0 is equal to A epsilon 0 divided by D. Second, let E0 be the electric field intensity between the plates before the introductions of the electric slab. Then the potential difference between the plates is given by V0 is equal to E0 into D, where E0 is equal to sigma divided by A epsilon 0 is equal to Q divided by A epsilon 0 and sigma is the surface charge density of the plane. Third, let's the dielectric slab is thickness T is greater than D be introduced between the plates of capacitor are shown in figure. Dielectric slab in the capacitor is diagram आहे. Fourth, the field E0 polarized the dielectric inducing charge minus QP on the left side and QP P of the right side of the dielectric. 5. This induces the charge set of field AP inside the dielectric in the opposite direction of E0. Induced field is given by EP is equal to epsilon P divided by epsilon 0 is equal to QP divided by A epsilon 0. Therefore, sigma P is equal to QP divided by A. 6. The net field inside the dielectric reduced to E0 minus EP. Therefore, E is equal to E0 minus EP is equal to E0 divided by K. And therefore, into bracket E0 divided by E0 minus EP is equal to K, where K is a constant called as dielectric constant. Therefore, K is equal to Q divided by A epsilon 0 into K, or Q is equal to K epsilon 0 into E, equation second. 7th, the field AP exists over a distance t and E0 over remaining distance d minus t between the capacitor plate. Hence, the potential difference between the capacitor plates is V is equal to E0 into bracket d minus t plus E d into bracket t. Bracket complete. E is equal to E0 into bracket d minus t plus E0 minus divided by k into bracket t. Therefore, epsilon 0 E is equal to A epsilon 0 divided by k into bracket complete is equal to E0 into bracket d minus t plus t divided by k bracket complete is equal to q divided by A epsilon 0 into bracket d minus t plus t divided by k. The 8. The capacitance of capacitor on the introducing the dielectric slab becomes C is equal to Q divided by V is equal to Q divided by Q epsilon A epsilon 0 into bracket D minus T plus D divided by K bracket complete is equal to A epsilon 0 divided by D minus T plus T divided by K bracket complete. This is the required expression. Question number 3. Derive an expression for electric potential due to an electric dipole. Answer first. Consider an electric dipole. Let its origin be the center of dipole as shown in figure below. Electric potential due to an electric dipole. Yeah, diagram. Second, let C be an point near the electric dipole at a distance r from the center, O inclined at an angle theta with axis of the dipole. Let r1 and r2 be the distance of point C from the charge plus q and minus q respectively. Third, the potential at C due to charge plus q at A is V1 is equal to plus q divided by 4 pi epsilon 0 r1. Potential at C due to charge minus q at B is V2 is equal to minus q divided by 4 pi epsilon 0 r2. Fourth, the potential at C due to the dipole is Vc is equal to V1 plus V2 is equal to q divided by 4 pi epsilon 0 into bracket 1 by r1 minus 1 by r2 equation first. 5. By geometry, r1 square is equal to r square plus l square minus 2r into cos theta. r2 square is equal to r square plus l square plus 2rl cos theta. r1 square is equal to r square into bracket 1 plus l square divided by r square minus 2 l divided by r cos theta. Bracket complete. r2 square minus r square into bracket 1 plus l square divided by r square plus 2l divided by r cos theta. For a short dipole, 2l is less than r, and if r is greater than l, there l divided r is small. Therefore, l square r square can be neglected. Therefore, r1 square is equal to r square into bracket 1 minus 2 l divided by r cos theta. r2 square is equal to r square into bracket 1 plus 12 divided by r cos theta into bracket complete. Therefore, r1 is equal to r into bracket 1 minus 12 divided by r cos theta 1/2. R2 is equal to r into bracket 1 plus 12 divided by r cos theta into bracket 1/2. Therefore 1 upon r1 is equal to 1 upon r into bracket 1 minus 12 divided by r cos theta into bracket minus 1 divided by 2, and 1 upon r2 is equal to 1 upon r into bracket 1 plus 12 divided by r cos theta into bracket minus 1 divided by 2. Equation second. 6 using equation 1 and 2, Vc is equal to V1 plus V2 is equal to Q divided by 4 pi epsilon 0 into bracket 1 upon R into bracket 1 minus 12 cos theta divided by R into bracket minus 1 divided by 2 minus 1 upon R into bracket 1 plus 12 cos theta divided by R into bracket minus 1 divided by 2 into bracket complete. 7th, using the binomial expansions into bracket 1 plus x raised to n is equal to 1 plus nx, x is less than 1, and retaining returns of the first order of L divided by R. Only we get Vc is equal to and Q divided by 4 pi epsilon 0 1 upon R into bracket 1 plus L divided by R cos theta into bracket complete minus 1 minus L divided by R cos theta bracket complete. Therefore is equal to Q divided by 1 upon 4 pi epsilon 0 R into bracket 1 plus 2L divided by R cos theta minus 1 plus 2L divided by R cos theta into bracket complete is equal to Q divided by 4 pi epsilon 0 R into bracket 12 divided by R cos theta. Therefore Vc is equal to 1 upon 4 pi epsilon 0 P into P cos theta divided by R square. Therefore P is equal to P into 2L bracket complete. 8. Electric potential at C can also express as Vc is equal to 1 upon 4 pi epsilon 0 into P bar into R bar divided by R cube. Therefore Vc is equal to 1 upon 4 pi epsilon 0 into P bar into R cap divided by R square into bracket R cap is equal to R bar divided by R. Therefore R cap is equal to R bar divided by R bar bracket complete, where R is unit vector along the position vector OC bar is equal to R cap. इथे आपले सर्व लॉंग आन्सर क्वेश्चन संपलेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.